You can hear me, you can see me. 3, 2, 1. You should now see me also. You should see my desktop. And we are about to start. Let's see. There's been interesting feedback that came in from the last session. Some of us are at various different stages of learning. And that actually was interesting. I expected that. What I was just checking is if you can hear me and see my desktop, which is currently a white screen with my scribblings. So just need some feedback. If you can hear me, audio level okay.
Yes,
we can
Okay,
hear you.
good.
Yeah, I can hear you.
Sweet.
And I can see
And
you.
yes, nice. So the feedback in short was that some of us in the group already know quite a bit of infrastructure, and maybe those people think that the cloud technologies segment is actually like a review of okay, what's going on. And so I understand that. I also understand that others are not at that level of experience dealing with bits and pieces of infrastructure. So it is what I'm trying to accomplish in the program is to make sure that I address the needs of the mainstream group in a live session. And then for those who are advanced, I like them to go ahead and proceed and pursue their interest. And also those who are slightly behind should also pursue their interest, but again, not in the main program itself, in the main video sessions, but in a separate one-on-one session, maybe a smaller group session. And I think that is something that I really encourage. And I respond and I interact with many of you already, by the way, on a one-on-one session or something like that. We should do that more often. And another piece of feedback that I had, which is, I think, something that I have not been paying attention to, which I should, is that this tool that we use, the Zoom conferencing tool, allows us to informally provide feedback in a runtime live session. What I mean by that is that there is this thing called go faster, go slower buttons. They're there. There are also other buttons probably here, which is like a clap, or need coffee time. And what happens is, if somebody wants to tell me, hey, please stop and go faster, they cannot really practically do that. Even though I encourage all these things, it becomes awkward.
I don't recall that at all.
But not a particular person. I'm not naming anybody. But what I'm trying to suggest is that maybe we can use informal tools like this. Like this is very anonymous.
Oh, well,
it becomes awkward for somebody to.
Because yeah, I do need to see Dr. Kang, so that's scheduled, or I do need to schedule that too. He's in.
So I think somebody's going to see the doctor. But what I was talking about is the tool that we have to tell me go slower, go faster is available in Zoom, and it doesn't disclose publicly doesn't disclose who is clicking that. So you can basically anonymously tell me to go faster, go slower if you like. Also, things of that. I think that's the thumbs up, thumbs down tool, maybe a clap tool, or those kind of things are available. I will pay attention to those. I was not paying attention to that, so I am encouraging that you use that if you like to. Don't have to, but maybe I will. This is the first time I'll be actually making use of those visual clues, which are anonymous, but give me some feedback, which may be awkward for some of us to give, like saying, hey, Nilesh, go faster. Maybe skip this, move on. I think that feedback is necessary for me to act on. So, and at the same time, people don't feel comfortable. So the way to, that Justin is telling us, everybody, that click the participants icon at the bottom of the Zoom window to open the feedback options. That's how you open. And that's where you can actually maybe tell me to, okay, now shut up and move on, something like that. So you should do that. I mean, I encourage all these things. So somebody raised a hand like that. So that's beautiful. If you actually meant to ask a question, please raise the hand again. And I will look, I'll pay attention to these signals, which I have been generally conveniently ignoring because I never bothered. I just focused on these Slack chat conversations, which we have been having all along. So that's what we will continue to use. But let's see. So Let me shut off some of the windows that are not necessary here. For example, this is not necessary. Slack is, Zoom is, and Notability is the notebook. Okay, now let us go some of the other aspects that I think I was chatting with someone I think I was chatting with as to what do we intend to cover. And I have a short list here that I wrote down as to what I intend to cover. So today, what I intend to cover, I'll maybe just use this notepad to write it down. So here it is. And let us see if we can make it a little bigger. So aspects that I want to cover today is an extension of the idea of building the VPC thing from scratch. We'll focus on ideas such as one of the most important ones is security. And one of the fundamental building blocks of security inside a virtual private cloud is, as you may have known already, is the idea of a security group. So it is called SG, or security group for its full name. Let's go see what that basically boils down to when we are looking at an example security group. So I will go to Amazon console, by the way. Amazon, not this Amazon. Actually, the same company, but console.aws. That one. So the Amazon console I'm signing on to. And actually, one of you somebody asked as to what do I use to just randomly quickly log in and also provide a login token. So the tool I'm using is 1Password, which is something that you may find useful also, is to just automatically generate a login token and lets you log in very, very quickly, efficiently without having to struggle to grab that token. 1Password is my tool of choice, which is not free, by the way. So the free tool of my choice is this. This tool is pretty nice. It simplifies your life in managing your password if you want to. Uses a browser-based, cloud-based storage, and you can authenticate and basically manage. So look at it. If you like it, use it. LastPass. Not open source, but it is free. The open source versions is KeePassX. That's the open source implementation. There are other implementations also to manage passwords and login names. Take a look at these products if you are interested. KeePass is an open source product. Okay, so what I'm talking about VPC again. And like VPC, the Amazon calls it virtual private cloud, and we built one ourselves. We have these two VPCs, the leave it alone VPC that we got to begin with. And another one is this one we created by hand called Cloud Genius VPC. That's what we have, two of them ready. We'll focus our attention on this VPC, not the other one. Every cloud company will have this kind of a structure called a virtual private cloud, and they will have building blocks pretty much like the subnet, the routing tables and gateway and egress-only gateway and all other things related to it, like a NAT gateway, for example. All of these cloud companies provide these things, pretty much everybody. Now, having said that, what I want to focus today on, at least to begin with, is the idea of security groups. And we created two of them the other day. If I remember right, if I focus on the Cloud Genius VPC, there are these three security groups available to us. One of them was given to us by default. The other two are the ones that I created. And if you recall that thing, you will find that the two VPCs we created, the two security groups we created was one for the application, which is this, the other one for NAT, which is this. And if you carefully pay attention to the inbound rules for NAT, inbound rules for NAT, the inbound rule allows me to get in from my IP address. This is inbound using SSH protocol. That's the NAT rule. Next, the outbound rules are generally open to anywhere you want to go. So everything, all traffic to any other location on the internet, all permitted. That's the initial chosen design that I began using this with. Similarly, the application security group is also very, very similar in terms of outbound rules. All traffic can go anywhere they want on the internet. 0000/0 represents the internet, the entire internet. And the inbound rule for the application security group, what I did was modified it to actually say that I want to be able to come in from anybody who is in this security group. What is that number? this 14559 is actually the NAT security group number. That anybody who belongs in this group, in this group, can come in to the machines that are in the app group. That's what this inbound rule says. As long as you are a part of the NAT group, you are welcome. You can come in. All traffic allowed from NAT. That's the modification I did for us to be able to go inside in the application machine that I had created in the application subnet. So let's draw that picture again, which we had to begin with. So we had these two subnets, the public subnet, the private subnet. And here I had one machine called application. This is generally under the control of the application security group. And that applies to this machine. There was another machine called the router. And this had a separate security group called the NAT security group. And that controls the behavior of these machines, specifically only the NAT. And if you are in the member of this group, you are allowed to come in. If you are a person like me, in my home, very specifically in my IP address, then you are allowed to come in. That was the limit that we put on this group. And then this group says you can come in. If you're here, you can come in. That's how we structured. So if you now take a step back and understand what security groups actually are. Security group is basically a collection of rules. Collection of rules. A rule of two types. There is an inbound rule. There is an outbound rule. And we have to pay attention to these rules very carefully. Otherwise, it will lead us to confusion as to why something doesn't work or why this works and that doesn't. And all those questions will come into play and we will not be able to answer if you don't understand what these things are. So generally speaking, they're classified into two parts, in and out, inbound versus outbound. But from an actual implementation perspective, a security group is basically a collection of rules in these two big buckets. And in each one of these buckets, the rule, like a rule, like rule number 1, rule number 2, like that. These rules will be basically allowing us, where do you originate from? So let's say the origin, which protocol and port, proto and port are allowed, and rather you let's go an example. So origin was my IP. The protocol was SSH, port number was 22, and whether you allow or not. That pretty much is one rule. So allow or not. Either you can allow or disallow. Disallow doesn't need to be an explicit entry, you just don't have the entry. So anything that is allowed is entered in form of a rule. So IP address, my IP, port number, protocol number, and whether you're permitted or not. If you're not permitted, then there is no entry. So if there is no entry allowing you, you cannot go in, given it's an inbound rule. And going out basically applies to a traffic originating from somebody inside the group trying to go somewhere else, outbound traffic, which is generally kept open because we trust our own machines that they will not go to wrong direction, not visit random locations, and assuming that our servers are in our control, so we know what they're doing. So that's why generally most of the cases, the default choices are allow everything to go anywhere as long as they are in our control. So basically permit everything. That's the default choice that you will see, if you go to here and try to create a new rule, for example, like a new security group set. And let's go create this one for my databases. And so for the database security group, I will put this in the Cloud Genius VPC. Just create a group like that. And it will come with some default choices. Let's go see what those are. Once we see them, we'll find out. So for database, I have no inbound rule. So begin with security in mind. Everything is logged out. Let's see outbound rules. Everything open. All traffic, anywhere you want to go on the internet is allowed for outbound, but inbound, nothing allowed. That's the default selection choice given to us by when we start with an empty security group. Having understood this part, the most focus we want to actually pay is not here, not too much here. We'll still pay attention to that, but most of the focus is towards the inbound rules. What can come in from where it is originating which protocol, port number, traffic type is coming, whether it's TCP or UDP, which protocol are you using, which protocol handler, and the port that we are using, whether we allow that or not. That's the primary focus of attention when constructing this collection of rules, which Amazon calls security group. Google will call it firewall, and that's totally fine. It's just nomenclature. Other companies call it security group. Some people call it firewall. So I think that's the names. There may be other variations to the same thing with a different name, but they're all talking about the same concept. Now, this security group implementation comes from this package software, which is typically the NetFilter project or the IP tables project. This is where it is built into Linux machines. It is available on every machine that you can think of. However, the security group discussion we are talking about is separate from the machine itself. So here is machine number 1, 2, 3. Each one of them will have their own implementation of IP table rules as a firewall rule. They will have those rules inside in the machine level. You can choose to use them or not use them, your choice at the machine level. But what this security group concept provides us is something outside the machines. So, if you put these 3 machines in a collection, call them a security group for, let's say, applications, then this rule set is not really dependent on any one machine here, but it's applied to the collection of these machines together. And then those rules that we talked about apply. So rule number 1, rule number 2, like that. Those rules will apply to the behavior of traffic going to or coming out of this little box, which I defined as my collection of rules. So having understood this piece, now if you want to set up, like I just created a database security group, right? You saw me do that, this one. The reason I did that is to actually illustrate a new point. The point I'm trying to illustrate is that I would like to now have another place to run my databases. So what I will do is I'll expand my design. What I want to do is, initial design that I had, I'll now begin to think about storing data and things like that. That's the reason why I introduced the idea of database. So we will have one public, which we already have, one private subnet, and we'll create one more subnet here. Let's call it the database subnet. Okay, there we go. Notifications, do not disturb. So here is your application subnet, and here is your, or what was the name I used? Public, and this was called private. So I want to actually rename this to be more meaningful, and I want to call it application subnet. This is my database subnet. This is going to be my public facing subnet. I can rename this one to something more, even more meaningful, to say that this is my border checkpoint. Border check. You can basically name it whatever you like. I'm just choosing fancy names today. So I'll go back and rename this guy. Application subnet is the one that will store my applications, which is what I have in mind. So that's good. The public subnet that I had, where is that? So this is not the subnet. So let's go subnets. This is the public subnet. So I want to change it to border check. As you will see, these are just names that I am allocating so that I can basically think of them as something of my interest. So I just application as a subnet, border check as a subnet, but then I'm talking now database. So I will create a subnet to hold my database. And so I will do that just now. What I again intend to is look at the CIDR, CIDR, in this, which we have used. The examples we used were 10.0.1.0 and 10.0.0.0. That was the 2 example CIDRs that we used while creating the border check subnet and the application subnet. So this was 10.0.0.0 and this was 10.0.1.0. So I want to put this database subnet as something like 10.0.2.0.24. This is again totally my choice. So I can choose whatever I want here. But that's my intention. So I'm expressing my intention to this cloud service company that I want to get my database subnet created in the Cloud Genius VPC, and the CIDR block allocation should be 10.0.20/24. And then I create. So that gets a new subnet for me. And it's getting created. And it should be ready. So now I have 3 of them. Now, I want you to realize that these subnets really have no one-to-one mapping with security groups. They don't have to be like that. You can put items in a different subnet in another security group. So security group is like a collection of rules that can span multiple subnets. It doesn't have to be strictly limited to only that subnet can belong to the application security group. No, it is not like that. You can mix and match and put items in various subnets or various security groups as you like. There is no such artificial limitation that you have to put databases in the database security group like that. There is no such structural limitation. You can put a machine D1, D2, and a machine application 1, application 2, and some other machine like routers and jump boxes. You can put whichever group you like. So there is no one-to-one mapping. This mapping doesn't exist. It is only in your mind that whatever you want, that you think is the right behavior, is what you take into account and construct a collection of rules, which is what a security group essentially is. So we can have an application security group, and we can, logically put these 2 guys in the application, and that's great. But nothing prevents you technically from putting this machine also in this group. You can. It doesn't make sense, but you can. I mean, nothing technically prevents you from doing it that way. I would rather not, because it doesn't make sense, but you can technically. That's what I was pointing out. Similarly, another security group will have a database. And in the database, we can mount these 2 machines together and associate them in the database security group, like that. So now, from a simple example to put in place, if you want to run some application that I want to say run the WordPress application, like I discussed the last time, we have to have these things called LAMP, which means there are these pieces of Linux, which is pretty much every machine, Apache, which is our application server, MySQL as the database, SQL is the database piece, and PHP is the language which will run the applications. We have to have these pieces together. And so what I want to do is actually move this item separate and put these things together on one box, and have a separate box that will run Linux and my database server like MySQL. And that will allow me to separate my database away from this one application server. So imagine this as my application box, let's call it A1. And this becomes my database box called D1. I can construct machines like that and put them in here. The same 3-part subnets we have, the border subnet, the app subnet, the database subnet. We can have a Linux machine here running MySQL software, which becomes our database server. That will, let's call it D1. This machine is running Linux and running Apache and running PHP. This becomes my LAMP host, LAP host, because M is here. And so this becomes my A1 machine. This is my D1 machine. And now you can think of structuring these guys together in terms of putting them in appropriate subnets, putting them also in appropriate security groups so that you can control traffic. So when it comes to security group, what I want to actually do is this database that I know, MySQL, it listens on this port. So I want to open up this port onto the database security group. This should be open, but it should be open only for these guys to come in and connect. I don't want anybody else to come in and connect to the database. People outside, they should not. The machines here, the machine jump boxes and other things coming out from the outside, no, I don't want that. Only thing that should be able to connect is the application. This is okay. Everything else is not. So I will structure my database security group pretty much like this. If the traffic originates from the application security group, allow port number 3306. That's the kind of structure I want to put. So I'll go back to my security group structure, look at the database security group, and the inbound routes are basically empty. So I will edit and create a new one. And a rule I want to put is specifically that port number 3306, which is, where is MySQL? There. So 3306. I'll select that and allow this port number comes up. And I want to keep my sources limited exclusively to the people that, sorry, the machines that belong in the application. So right there, click. And then I'll say here in the notes section, for me to understand what I'm doing is to say that, this group allow applications to connect to database. And then I save. So that is my definition of an inbound rule for the database security group, which allows me, or rather, which allows my applications here running this LAP. Whatever apps I run, A1 will be able to connect to this port in the MySQL Server deployment I have here in the database machine called D1. Now, creating this database machine is very simple. You install and set up a box called D1 running Linux, and then you run one command, something like this: apt install MySQL. That's it. You're or rather server to be specific, and you're done. You get a MySQL database server like in 3 seconds, maybe 5, and you have to specify your root password, and then it sets up. That's all it takes to set up a database in a simple example. However, that's not how these cloud companies suggest. There's nothing wrong in using it this way, though. There's nothing wrong in using this kind of setup. It's just a lot of work to now manage your database backups, a lot of work to keep your data protected and all that. So you have to really then become a database administrator if you are running your own database server. This is totally fine to go like that, and totally okay to have your own machine run your own database application, to become a database server and all that good stuff. But then with that flexibility and the power that you get, you get responsibility of maintaining, managing upkeep and backup and restores and everything else that goes along with maintenance of data. So what companies like Amazon will suggest is that you don't use that kind of a method. But what rather they would do is have you come here and select relational database service and try to, first thing first, pick the right region. So like Oregon that I have, and then get started. And when you do that, they'll give you a ready-made database service. What does that boil down to? Is basically you get them to, you offload your work to them. So if I want to run, let's say, MySQL database, I'll just select MySQL. And you can make sure that you can limit yourself to the free usage tier. And that way you don't have to waste like money because it's going to be free. And then you go next. And you select the database engine you want, the version you want, and maybe this is 5.7.19 is the latest. So maybe that one. And then you can basically give it a name, some kind of an identifier here, and some master info like root and the password you want, like 123 is my favorite password. I'm just kidding. So that's the password that you select. And okay, let me just select this password, fine. And then you go next. And when you do that, it is going to let you select the VPC where you want this to be created. So you select the right VPC. And whether it's going to be publicly accessible or not, you don't want the database to become, you do not want the database to be publicly accessible. So you say no. And then you create an existing, rather use an existing security group that you have. For example, we have chosen the database security group. So we'll select that. And you may want to remove this if you don't want it, because we are already manually managing our database security group. So we don't have to. You can select a database name here, like whatever name you want, the port number. And you then also enable some backup, backup retained for every up to 7 days. And you can select the window on which you want, the time window on which you want to back up the start. And you can enable monitoring if you like. And then you go and allow it to automatically update minor version upgrades. So they'll basically help you manage the database solution for you. And when you launch the DB instance, you get a database server. Then you don't have to worry about it because they are managing the responsibility. They charge you for it unless you are on the free tier. And they will maintain and upkeep the database application, do the backups and restores and all that good stuff. Is a nice fancy service. And maybe it's a good idea. Maybe that's a better idea if you don't want to manage your database solutions yourself. So those choices are available. Now you can choose that my database service that I just started is belonging in this security group, so that it will follow the discipline you are trying to put together, allowing your applications to connect to the database service that you chose as opposed to the database server you created yourself. So you have the choices. So with this understood, now let's move on to the other idea, which is, let's say if you have a database here, D1, running database, application 1, connecting to the database on port number 3306. This application typically exposes itself on port number 80 or port number 443 for HTTP protocol or for HTTPS protocol, depending on your choice. However, we know this, that these machines, A1 and D1, are not publicly accessible. So what's the point of running this thing here when nobody can visit? So I want to go http whatever.com. I go where again? That's a big question. I want to really go here and I want people to come there. But I deliberately chose my machine to be inside a private subnet. And so that's the deadlock now. How do I resolve it? I want people to at least come to this box A1, and this border has my router. It has a jump box also somewhere that I occasionally use. But then people will come in through these ports, HTTP, HTTPS, and so port number 80, port number 443, and I want to be able to respond to them, but where are they going? Are they going to the router? No, the router doesn't allow any traffic. Let's see what the design is in our router. So we go back to our AWS and look at our VPC, and the VPC has a NAT security group, and the NAT security group doesn't allow any inbound traffic other than me going in from my location. So this is my IP address. That's the only traffic I'm allowed currently. So how will these people, like people on the internet, my customers, how will they come in to this and this port on this machine?
Install load balancer.
Yes, load balancer. So load balancer needs to be installed on a public section, like border check subnet, public subnet. That's where we need to put in a load balancer. A classic load balancer on the internet, which is very famous, is called HA Proxy. This one looks like a Craigslist website, honestly. It looks more like this. But let me tell you, don't go by the looks. This is a fancy software. Big companies use it. And it is highly capable and purely open source, and the latest version is 1.8.0. It is also behind this big company called F5 Networks, you may have heard of, which is primarily, that's how they began. So this F5 gives you a load balancer service. Under the hood, F5 uses HA Proxy. You may have also heard of AWS, the company we're discussing right now, Elastic Load Balancer Solutions. These guys give you a load balancer like that one. So we'll go to that location, find out what they give you. And this is also a derivative of the HA proxy implementation. It's not directly exactly HA proxy. They basically use this underlying reliable, high performance HTTP TCP load balancer. Under the hood, that's what they're using. So let's go see what they do. If we now look at the load balancer, what it actually does in very, very simple terms is let's draw a picture. A load balancer will look something like this guy. And what its role in life, let me draw the picture again a little bit. So I'm erasing this right now. Erase. What I want to do is draw this more structurally correct. So here is my subnet, and here are two other subnets that I have. So copy and paste and paste. So 3 subnets. Let's go put them here. And now this is the subnet. This is the load balancer I want to actually create on top of my public subnet. This is my application subnet. And this is my database subnet. So I will put my database instance and mount it right on there. Something like that, right there. And these guys are just not only one. So we'll just put this on the application subnet like that. So pictorially, a little bit more resembling what I had in mind as I was discussing is the database subnet, the application subnet, and the border subnet. With this understood, people on the internet, like these guys, can come in. They will be able to visit here. This is the point that I will expose to the world outside. So people will use mobile devices, laptops, desktops, and visit this using the port protocol HTTP, port number 80, or HTTPS, port number 443. Those two are typically used by people using browsers and applications and connecting to some kind of a website, some service that some company provides. So they come here. Now, what the function of a load balancer is to balance load. Very, very simply speaking, that's what they do. Balance the load. But balancing the load among what and who? That's the next logical question. So those of you who do not know what a load balancer is, let me give you a quick example. And the example goes like this. You are at the Department of Motor Vehicles. You're trying to get a driver license. And this is called Department of Licensing or Registry of Motor Vehicles in other states and other countries and different licensing office. So you want to get a driver license. So you go there. You go and you stand in line. There are other people waiting. And there are these desks. Desk number 1, desk number 2, desk number 3, like that. And so the desk number 3, there is no officer. Officer number 3 is not there. Officer number 2 is out for lunch. And officer number 1 is sitting like there. Yes, he's there. So you have these guys waiting in line. And when as you show up, so what happens is these guys are then allocated to you should go to this officer at that desk. And so this person goes there, but then this line is accumulating so that, what happens is this person comes back from lunch. So officer number 2 is now back from lunch. There are 2 desks available. So there is going to be another person here, like the cop, who will say, Mister, you go there. And these 2 will wait. And then these 2 desks will handle these person number P1, P2, like that. And P3, P4 are waiting, and there are more people accumulating like that. And so lots of people coming and waiting in line, and they're getting frustrated. And the idea is this cop is trying to say that, if people are waiting in line, let's find some more people, some more officers, and let them work on more desks. So we'll open up more desks as people start to accumulate. We'll bring more officers to serve the driver licensing needs of these people. And so the role of this cop, or let's call it somebody else, some person out there in the office, will guide, you should go here and you, sir, should go there. That decision is made typically by this person. And you can see this in as you enter another country or maybe go to driver license office. That's the allocation. So in our pictorial example, what typically happens is the load balancer here in question, which is this guy. He or she, or rather that machine, is balancing load among multiple such application servers. Like we'll have more like that. And so now we have 3. And so this machine will be able to balance the load between multiple people. That's the classic design idea behind multiple people waiting, and you want to make them everybody happy. So you balance your load of these people. That's the load that you want to serve them. That's a workload, actually, to be more specifically. It's a workload. You want to balance your workload among multiple machines. And therefore, you use another service or a separate box that runs maybe this software, like I mentioned, HA Proxy. It runs this software, and that will let you balance the load very efficiently. By the way, this HA Proxy is a very efficient tool that does this job very, very nicely. So this phone user comes in and it says port number 80, please. So tell me where I want to go. And then it will say, you should go here. And so the phone user goes here. And like that, other people will be sent to other boxes. Now, when you're looking at this design, I would like you to pay attention to the idea that when we are dealing with these kind of machines behind a workload balancer, like I mentioned here, the expectation of these users that we have here, these people, is that each and every one of them will get more or less similar experiences. Okay? For example, if this is Facebook, the whole thing, then this person uploads a picture and he is going to go tell the neighbor, hey neighbor, I uploaded a picture of my dog yesterday. Did you see it? Now what happens is, if you have this person who uploads this picture P of the dog, the picture goes to the load balancer and then says, you should go here. The picture gets saved in this box. Now this other person, the neighbor, comes along and say, hey, I want to see the picture. So let me go and see. And so the load balancer will then point them to this box. Say, you should go there. And this next door neighbor will say, hey, where is the picture? I don't find it. It's not here. The picture is missing because the picture is sitting there. And that is a problem. Right? It's a big problem. And so you expect that these people actually expect that the same experience is given to everybody. And so if the person uploads a picture, you want the picture to be visible to the neighbor. And so you want to have a method of systematically making this picture magically appear on all the machines. Just like that. That is a hard problem. And it's also another complexity comes into play when you see that these machines can like magically grow and shrink as they scale out and scale in. And so this problem even further complicates the problem of making sure that the neighbor is able to see the picture P that I uploaded here from this device. I want my friends to see the picture irrespective of which machine they go to. So how do we solve this problem? That is not a load balancing problem, by the way, but just something for you to remember the classic nature of a cloud-based deployment.
Shared storage?
Yes, exactly. You want to put this picture P not on these boxes. You would rather put that picture out somewhere else, like a bucket system. And so as soon as the picture comes in, like this guy put the picture P, you want to make sure that the picture does not belong on the boxes there, because it doesn't even make sense. You should immediately move that picture out from here. So say erase it from here, put it in a bucket in S3, for example, and put a record of that picture here, record of the picture, that my picture is sitting in this bucket. You put that record in the database, and thereby letting every other machine know that, you know, this guy, when he or she comes in, and so you see this, visit this box, hey, where is my picture? They'll look up the database, find out where the picture located, and then appropriately visit the bucket that you have in mind and grab the picture and say, oh, yeah, here it is. Here's your picture.
Question.
Yes.
So I understand the infrastructure. So databases normally don't have read locks, but how's concurrency managed on this at the storage? Yes, there.
So this storage is object storage, which means there is the item is stored with a put command, not a write command. So the concurrency issues are ruled out, right? You're putting the whole object there. So if you're putting, then you put the object. If you put another object, it's overwritten.
Okay, so the multiple users can read from the same object at the same time?
Yeah, that's how you see that. You know, you created buckets in the previous exercises, and you put items in your bucket, and you were able to see, and lots of people were able to open the website. It's like a public facing site that you created, right? Most of you, people who did the S3 homework, you created an S3 bucket, you put an item in the bucket, and that bucket was exposed to the public in a web representation, and people on the internet were able to visit concurrently, right? Same idea. So the point I'm trying to drive here is, don't store anything on these boxes. That's the one critical point. It is basically to remember that in our design, we want to make sure that we use a shared storage, outside storage somewhere else that doesn't make our machines. Let me give you an analogy here that is easier to remember. So the analogy is like this. It's easy for most of us to remember, because imagine now, I'll give you an example. You are in the state of Texas, and you are a cowboy or a cowgirl, girl or a boy, depending on whatever, but you are basically dealing with cows. You have a horse, and in your hand, in one hand you have a whiskey, and in the other hand you have a gun. And what you're doing is you're riding the horse and you're shepherding 10,000 cows. That's what's going on, right? That is you. On a horse, gun in hand, whiskey in the other hand, you're drinking, and cows are going, and you're shepherding them towards the destination. Along the way, one cow falls sick. What do you think the cowboy will do? That's the question. So you tell me.
Is cowboy a vegetarian?
I don't know. You decide. Whatever you are. So you have the gun in hand, and it's
You
the
don't
classic.
eat sick cows, guys. I'll tell
I know
you that from experience.
Exactly. You don't eat sick cows. So you have the gun in hand, and you have a whiskey glass in the other. You're riding, and 10,000 cows in front of you. One cow is like sick. You don't want to like push the cow, because it's like you have to go at the destination on schedule. So you're shepherding these cows. You need to be there with all the cows. So what do you do with the one cow that is sick? What do you think the cowboy will actually do?
You always separate that cow so it doesn't get the others sick. But that's a
Yes.
biological. Maybe not what you're.
The immediate response that I hear from most people when I ask this question is that he will or she will take the gun and shoot the sick cow and move on. Is that logical? I don't know. You tell me. That's the answer. Yeah, it's logical, right? Is it?
Yes.
Okay. So that is exactly how I want you to think about these machines. They are cows. They are not your puppies. That's what I want you to remember. So on the other hand of this story, the other story is if you have a puppy and a family of like 3 people, like mom, dad, and a child, and these people, have one puppy and the puppy falls sick. What do you think these guys will do, the family? They'll take care of the puppy, right? They take it to the vet and all those things that you expect a family to do for a nice little puppy is to take care of the puppy. They're not going to pick up the gun and shoot the puppy, right? It's a very different game. So now, why did I give you these 2 examples? But I want you to think about these machines out here. Actually, the whole thing, you want to treat the whole thing like a cow and not like a puppy. That is something I want you to remember. When I say not like a puppy, what I really mean to say that cloud is like cattle. And your data center you have in your office and the machines you have inside that data center, you carefully manage them. You label them with fancy names sometimes. You give them like a name of a puppy. But you typically don't name cows, cow number this, cow number that. You brand them occasionally, but don't even bother naming them unless you actually fall in love with the cow, which is a different story. So think data center, think like puppy. Think cloud, think like cattle. What does that really do? If in your design, in your implementation, if something goes wrong, you just shoot the whole thing and create a new one in like few minutes. That is a possibility. If something goes wrong, don't worry fixing. Move on. That's how you should think, at least to begin with, when you are dealing with cloud implementations. And we'll elaborate more on this with specific examples as to what I mean by shooting the cow or think like a cowboy or cowgirl is to not fall in love with your machines, because these machines should be ephemeral. What you really want is to make sure that your data is intact and is actually somewhere else. So we know that these bucket solutions that Amazon provides is kind of a very durable solution. They give you guarantee of 11 nines, which is reasonably high. So if you know the 99.99, how many 11 nines? 11 nines we read about the last time. It's a good, highly durable storage. Use that. There are other storage solutions. They give you high quality, durability, and reliability and availability. You should use those storage systems. But remember to not store stuff on these boxes. As such, you don't store anything on the load balancer because it's just a transport service. It hands out traffic. You tend to store something on your servers that you create, and I would rather you not. I would not store anything whatsoever here unless it is disposable. So treat these as ephemeral. And I can demonstrate this live. What I can do is this site that you have, that you're looking at, maybe you log in here all the time. This site is strictly designed according to what I'm describing. And I will demonstrate to you live that I will take my gun and shoot the boxes right in your face. And within a few minutes, you should see that the site continues to work. Why is that so? We'll do this live example. I will be doing this. That happens because these boxes, I treat them like ephemeral. So I store every single thing that is of pertinent use to you and to me outside. Nothing here, which means I can actually take my gun and shoot all these boxes and they go away. And when I do that, I have resilience in place, resilience algorithms in place that will put these boxes back online, to create new boxes and put the code back in place so that it runs again and picks up the data automatically again and keeps on running. That's the characteristic of a Kubernetes cluster, which is self-healing, correcting, and it can handle transient disasters or boxes going down. So you can basically, shoot any of these boxes, maybe all of them together. And it will automatically create any number of boxes that are needed in your deployment. and bring back all the connections, all the things, all the code in place in a matter of minutes. And if you have more than 3 such boxes, then you can kill any box one at a time. It will keep on running your applications for these people without causing any downtime. You can keep on shooting boxes one at a time, maybe 2 at a time if you have more, and no downtime is seen from outside. That's how the design is. So that's what I want you to think, is when you are dealing with our situation of cows versus, there is, by the way, there is this discussion you will see. It's called pet versus cattle. So in short, simple terms, this is your data center. This is the cloud, C-L-O-U-D. That's how you should think when you are operating in the context of cloud, is just get ready to shoot machines and move on. Don't bother fixing them. You can always fix them, but it's a waste of time. You would rather create machines that don't have the issues to begin with. After briefly discussing this idea, just remember that we'll come back to this idea again and again as we go along. Back to here. In our load balancer setup and deployment, the idea is very, very simple. Now Amazon has recently introduced a network load balancer and an application load balancer. So 2 distinctly different products. Earlier, it used to be just this product, the classic load balancer. That was the case before. It is the previous generation. It is basically a combination of the first 2, this and this together was here. HTTP, HTTPS on one hand and TCP on the other hand, all together were there in the previous generation load balancers you can create. But these days they have 2 separate services. When you are dealing with TCP traffic as opposed to HTTP, HTTPS traffic, you can create either of those 2 types separately. And so let's go begin creating one load balancer. The thing that you will see if you give it a name here for, say, load balancer, and we'll make it internet facing, which is expected. And I would like this load balancer to listen on port number 80, protocol HTTP. So I add that, that's already added. And then I have this choice available to me of the VPC selection. Now here, I select this US West 2 as my, my cloud location, Oregon. And then it tells me that I have the choice of one of these 3 subnets. So I want to choose the border check subnet. That's where I want this particular load balancer called LB to go and get set up. So it will be an internet facing load balancer listening on port number 80. Maybe I want to add one more listener and say HTTPS and 443. And so listen on these 2 ports. For the traffic, mount yourself in the CloudGenius VPC in the availability zone West 2B and use the subnet that I have, which is the border check subnet. And then I will configure security groups. So it says at this moment, you will notice that it says something that is important for us to remember, which is, it says at least 2 subnets are supplied. This is something I want you to pay attention to. 2 subnets must be specified. Why is it saying that? The simple answer to that question is that all up till now in our design that we have been discussing and playing along in this 3-part subnets, and a border subnet, and application subnet, and database subnet, all of these things are basically not redundant. They are not, they don't have a failover capability. So this is something that we need to now introduce, because we expect a high-end application, a high-end enterprise application, to have some kind of a resiliency, to built-in resiliency in there, right there, which boils down to the idea that we have to pay attention to the capability of making sure that the availability of our application sets is high. If I just have one border check subnet and one application subnet and one database subnet, that is all basically tends to become a single point of failure. What I would rather have, and that's what this load balancer is hinting at me, telling me that I should use at least 2 subnets. What it is expecting is that it expects me to create another subnet for border check or public border. And this is border. Again, I'm doubling everything that I have right now initially to make sure that my infrastructure becomes highly available, HA. High availability is what I'm trying to introduce as a concept at the foundation of our design. What does that translate to? Is that I will have two for everything. So I will have an application subnet and another application subnet, a database subnet and another database subnet, like that. And I would like to have these guys in separate buildings, or rather separate availability zones, I should call. What is an availability zone? Let's ask that question. What does it actually mean? So if you now look back at Amazon, you will find that as we go along in creating our VPC, and in that VPC, we go and create something like a subnet, for example. When we create that, it actually says in your CloudGenius VPC, you want to give it a border check subnet, another subnet. It asks you this question, which I have been conveniently ignoring up until now. The question is availability zone. And I deliberately ignored this for us to understand the concept first before we jump into adding high availability options. But if you now come here and say drop down, they give us three choices: 2A, 2B, and 2C. US West 2A, US West 2B, like that. So US West 2 is Oregon. A, B, C are three availability zones. So from a practical implementation perspective, what Amazon typically does when they create availability zones is, let's say if this is the geography and you have some river here flowing, so river flows. And so what they will do is typically put their availability zones A and availability zone B on two sides, just to create that geographical divide. So for example, if something bad happens in this part, at least this part keeps on running. That's how they have structurally defined their availability zones. I'm just picking river as an example. It could be anything else. Like electricity supply lines go in this direction, that is hydro-powered, and in this part of this area, it is nuclear-powered. So you can then create this separation of availability of power supply for the machine infrastructure. So they don't disclose exactly how they call out and lay out their underlying availability zone differentiations. But to a user like me, when I go US West 2, they give me, there is a question coming up, these three. So let me read the question. The question, you're welcome to ask, Rob. Go ahead and ask the question.
Yeah, I wanted to know the difference between the availability zone and the data center that you're selecting, because to me, when you started talking about availability zone, I was jumping to, well, why don't you just put it, instead of in Oregon, put it in California or put it in Virginia? Or, that's, to me, the same idea. So what is the difference between those two ideas? Okay. Do you know what I'm asking?
Good question. So the question I'll paraphrase and then help everybody also understand the question is that the question that Rob is asking me is, when I say availability zone, why are we limiting ourselves to just US West 2? Why not have an availability zone selection across the US? So say, for example, on one end you have Oregon and the other end you have Northern Virginia. US East 1. Why not select one from here and one from here? B and A. That's the question. Is that what you're asking me?
Yes.
Okay.
That's exactly
right. So this is, by the way, yes, very good question, but not, Amazon doesn't allow this because it is difficult for them to implement. They have decided and chosen to implement their cloud in separate regions as separate clouds. In fact, you will remember if you put a key pair in this cloud, Oregon, it doesn't automatically flow to this cloud. It's a separate cloud to begin with, to understand that they are separate. The other challenge that you will find that gets introduced when you go like this, imagine Amazon allowed it. The real challenge comes into play is latency. The latency of applications between one load balancer managing here and here will make the application kind of unusable because of geographical separation. It is way too far away from each other. And so the application that we would expect, it will not function like you want it to function. There are other ways that we will be able to use to apply remote geographically distributed availability improvements. We'll talk about that later on. But in the Amazon design, this kind of an implementation is not allowed. For primary reasons are availability. And that's what you're looking at. So when you see these choices, you don't even get the US West or East choices at all. You are limited just, not even you get San Francisco. San Francisco,
Okay.
US West 1A.
Does Google or Azure implement that in a different way, or is this pretty standard?
Similar.
Standard.
They will have similar implementations.
Okay.
They don't go geographically spread out like that. You can put other techniques let me just give you a quick example technique of SRDF. This is my previous product. I used to work in a company called EMC about 17 years ago. And this product, I don't know if they still have it. They have it. So this is the product that I think your company uses. I don't know for sure though, is basically synchronous remote data facility. What this does is allows, this is very expensive to implement, but what it actually does is gives you an application that will run on some computer, which will say do a write operation on some DB, and the DB is sitting on a disk. And so the SRDF facility will actually be managing this disk write activity that application wants to save. And when you, without the SRDF situation, you will typically say, yeah, save the item on the disk, and the disk will respond with a acknowledgement. That's how typically it happens in a disk when you don't have such remote disk facility situation. You have a local disk, you write to it, you're done, you get an acknowledgement back, you move on, the application proceeds to the next step. But when you want to get geographic distributed higher availability, like the idea that you just mentioned, you need to introduce solutions like the SRDF facility into play, which means you don't get an acknowledgement back right away when you attempt to write. Instead, there are optical links that manage between two different disks. So this is disk number one, this is another disk in another state, another location far away, and this is an expensive optical link. And what they do is they get a write command, so it attempts to write to the disk, so it will write it here, it will replicate the whole thing onto this disk in the remote location, get the acknowledgement back from that location, and then say, yeah, it is written. And that is how the transaction happens. So this can be in, say, New York. This can be in New Jersey. And that was actually the example implemented. If you remember 9/11, the companies like big banks were using this kind of a facility, and we had a problem on that day. 9/11, big time trouble. You know the trouble. And yes, we had a big disaster. However, the data was not lost. Banks continued to operate, and they just resumed their operation from this location because they were able to actually ensure data consistency on a setup like I'm describing. This was the underlying technology used. It is available even today, and it's expensive, but that is not what I'm talking about when I'm saying high availability in the availability zone idea here. What we get is these guys within the same region, this Oregon region. So you can make the best of what you have. Like I will select, I think in the previous border check subnet was created in the availability zone West 2B. Let's go filter again here, and let's see where our availability zones are. For these guys that we have created, I want to find out where they belong. So the border check was in 2B. The application was also 2B, and database is also 2B. So if you don't specify anything, Amazon has given me 2B. Nice. What I will do is label them differently now, very, very quickly, say 2B, or rather B. And this one is your B. And this is my database B. And I will now create subnets, 3 more. And I need to plan these things carefully. What does that mean? It means that I need to, so there is a chat question. Let's go see the chat. Chat question is, does the AWS implementation of local traffic management include port checks and custom monitoring to make sure the app is up? Yes, it does. And then send notification if the app is down? Yes, it does. We'll play with examples like that. So let's get to that. So before we, that was a question that you have in Slack chat. So the thing that I want to make sure that I clarify is the idea that I want to create multiple availability zones. So let's use A and B, and create the border subnet, the application subnet, and the database subnet, and another border subnet, application subnet, and database subnet. But my numbering scheme is somewhat of not my choice currently. My CIDR block location choice is kind of clumsy in a way that it doesn't make sense to me, although it's not important. I must call out that it is not important. What I am really talking about is I want to write that down and make sure that you understand what I'm really going at. Is when you design a high availability subnet layout, you make it easy on your users. Currently, it can become a little bit confusing. What I'm saying is these bytes are indicators which subnet are we talking about. So what I want to do is make sure that I create my other 3 subnets in a fashion that continue to make sense. Something like this: 10.0, 10.0 /8, and 10.0, 11.0, /8. And this one, 10.0, 12.0 /8. And if I structure it like this very carefully, I can tell that they are together going to be the border checkpoint subnet. These 2 are going to be your application subnet, and these 2 as the database subnet. So you can structure your CIDR blocks in a meaningful fashion so that you will know what IP address belong to which subnet. It is not super critical, but a choice that makes sense to you and your users is a good one to make. Since I went around choosing this direction first, and then I'm going to create these guys, that's okay. I'm able to somehow make sense by the number 0 here and the number 0. I can probably tell that it is the border check subnet by this number 1 and this number 1. I can somehow in my mind tell myself that this is the application subnet, and number 2 and number 2 here. But the point here is to structure your subnet layout according to what makes sense to your business, to your customers, the users of this infrastructure. That's what I think you should keep in mind. So with this in my mind, I want to implement these sets of subnets right now. I will do that very quickly. Create a subnet. And here is my border check, and I'll call it A. And leave it to Cloud Genius and select the A availability zone this time, and say 10.0, what was the number? 10.0 /8, like that, and copy it, and then create that border check subnet like this. And say it's not in the...
Should be 16.
Oh, yes, it should be 24. Should be 24. My mistake. It should be 24 here, not 8. Not 8. So all these 8s are actually 24s. Just remember that. I wrote it wrong. 8 is weight. The whole VPC is limited to /16. So the subnets have to be smaller than 16. That is 24. So we'll use 24 here everywhere. So that is create. That was border check A created. Next one, Is it created or click? Did I click or not? No, I did not click. So create. Then we'll create two more, like application A and database A. And so that gives us the layout that we have in mind, which becomes slightly more available than the previous design. And so here is your application A, goes to the CloudGenius VPC and select the availability zone A and put the number in place. It's called 1, or rather 11, right? This one. And so create. And one more, which is database A. And so that gives us the two distinctly different availability zones constructed. If I begin doing like this, most people get thrown off. That's why I don't go that way of creating subnets. If I go that way, it throws everybody off who's never seen this interface before. It can be clumsy and daunting to just figure out where things are. It is a nightmare, somewhat. If you're doing it first time, you need to know where to go and things of that nature. So, but once you do it like 1 or 2 times, you get the hang of it. So database A, CloudGenius VPC 12.0, like that. Compare with my notes. Yes, it does matching. So I go create. So now I have 3 different subnets in a different availability zone. This time the availability zone US West 2A. And so I have this border check A and B now available, which means I can now lay out my high availability load balancer in Amazon's cloud right there, which means I will go to the AWS load balancer is in EC2 for some reason. So they club it here. If you don't find it easy, it is in the EC2 section, I think. Somewhere here you will find a load balancer right there. And that's where you can create a load balancer here. And so you can begin creating a load balancer of the HTTP, HTTPS type. You give it a name. Say, this is my load balancer. And it is internet facing. There is also this idea of internal load balancers for other designs. We'll talk more about that in a subsequent example. But right now, we are facing the internet. So the load balancer will actually serve our real customers coming from the outside, like these guys. So this should be public facing. It is on a border check subnet. So our design, we have just modified, by the way, a little bit. Our design includes, let me erase some of these guys. So I'll select a bunch of these machines and say, go delete. Oops, I deleted my subnet also. Okay, so what I now have is a collection of these things together and replicated like that. Except this is actually represented in the middle. So it sits on 2 different subnets. It's a service. It's a third-party service. And by the way, we'll be using our database as a service. So I just need to have only one. That's how we will design it. We'll also use some storage location. We'll use some CloudFront location as we go along, depending on how complex we'll make the application. But we will make it complex over time. Right now, I would like to have one machine here in this subnet, one machine here in that subnet. So the application A versus B. This is our B location. This is our A location. This is our application subnet, database subnet. And this one spans A and B both. And this is our border check subnet. That's how our design is evolving. And so I want to create this load balancer and tell it to use this and this 2 different subnets right there. So load balancer, internet facing, HTTP listener, HTTPS listener, 2 listeners, availability zone. I want to select the CloudGenius VPC. And here I want to select this subnet, which is our border check A. And then the second subnet, border check B. Now I have 2. And here, let's read what it says. You are connecting an internet-facing load balancer, but there is no gateway attached to the subnets you have selected, which is expected. This item, 791, which is the one I just created, this one, oops, the A subnet doesn't have a route table. So we need to fix the route table part. That's why it's complaining. So I cannot go without it. So I need to go back here and finish the other remaining pieces of that I did not create yet, which is in my subnets. I have 6. These guys, ABC, ABC, AB, 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 like that. I don't have 6 route tables. So I need to make sure that I use the public route table and the private route table. I can reuse them, but just associate them. Like the public one, I want to associate this and expand its association. Like this, I will edit the associations and include the border check A also in the public route table, associating it with this item. That's what I want to do. So edit, and just like B is already checked, I will check the border check A also, like this, and then save. When I do that, I am basically allocating a gateway connectivity, a route for this public subnets that I have now, 2 of them. And while I'm on the screen, I will also include in the private route table the other routes that I have, which are currently created, but don't have an explicitly associating them with the private route table. I need to do that. I have the app B already done from the last time. I will edit and expand my scope and say, get the app A, please, and get the database A and the database B. You can go like that, or you can create a separate route table, but it's really up to you. Database A and B and application A and B, all of them included. So I save, and now my associations for private routing is also included, although my private route is still in a black hole. What does that mean? That I don't have a NAT box because I killed it the other day, right? So my route to the internet is still missing. I still need a machine to act like a NAT for the machines inside, machines here, to be able to go to the internet. There is no way because there is no NAT box. So we'll need to create one when we actually run applications. But right now we are focusing on this idea, load balancer. So we'll go back to the load balancer screen right here and refresh. And it should tell us that, oh, it just wiped out the whole thing. Okay, so add another listener and select my correct VPC, and then select my US West 2A border check A subnet, US West 2B border check B subnet, and now it is ready for me to configure security groups. So I can go to the security group section, and here it is saying that you can get an, I think this is going to give us an ACM. This might, give us a way to create a certificate for us. So these guys, they have started a service to give us SSL certificates at the load balancer level, because we have chosen to select the HTTPS protocol. It is forcing us to select a certificate. So I don't want to unnecessarily complicate things right now. So I will remove my HTTPS listener for right now, and we'll proceed ahead. And so it says, you're not currently using any secure listener, which is fine. I understand. I don't want to go deal with security certificates right now. So I'm skipping that part. We'll revisit later on at another time. We'll basically use a third-party service for this idea. I prefer using this service, Let's Encrypt, which is a much nicer service to get certificates. It is nice because first thing, it is open source. It is free. It is automated and open. So all the big players you can see here are playing in that game. That's how I recommend using SSL certificates. You don't go to VeriSign and pay $500 or something like that. Don't spend money. It is open, and this is the recommended approach by all these people that are sponsoring. And also I recommend this, and the Linux Foundation also does. It is sponsored by them also. So this is the open authority to get SSL certificates today, and everything else we should not bother. There is no specific reason why we should not use this. I don't see a reason yet. There may be some other cases that I don't know, but I don't see a direct reason why we should not use this, and therefore I recommend using it. So which means we are not using it right now, which means we are skipping this particular screen and saying, yeah, we are not using secure listener, and proceed ahead. Which means the next screen is that we have to actually select an existing security group, which we don't have one by that name. So I want to create a separate group just for the load balancer. I don't have one yet. So I can choose that, you know what, create one, call it the load balancer. So let's say LB right there. And here I want to
Hey,
allow.
Noah, how did you skip that other one on the previous step?
So on the previous step, what I did was all the way previous, when I was here in this screen, I removed the HTTPS listener.
Oh, got it. Okay.
And when I remove like that, and then I said, okay, I'm not using security listeners, and fine, and proceed forward. That's how I did. So in the security group, I will create a new one, and that is my security group, which will allow. Now let's go revisit the idea of security groups here. When it comes to load balancer, my idea is I would like to have my load balancer receive traffic from outside, like people on the internet, port number 80, you are welcome. That's one group, one rule. The other rule that I would like to have is that these guys should be able to connect to these machines, which means the group modification I need to really do is actually in this security group, saying that, you know what, you please allow, if it is coming from these guys, please let them in, and only on port number 80. Don't let them go anywhere else, just port 80. If it is coming from the load balancer security group, the application security group inbound port should be opened to allow traffic coming from this guy. And this guy should allow anybody on the planet to come in from port number 80. So there are two parts that I want to create in the rule set. First part is for the new security group called load balancer. I want to allow anybody from anywhere to come in on port number 80. And on the other security group, I want to allow traffic, as long as it is coming from the load balancer, please come in. That's what I want to really say in the two security groups, the load balancer security group and the application security group. I want to allow these two rules. So I'll do that. First of all, load balancer security group, I'm creating a new one right now. So I'll say, you know what, HTTP port, just let anybody and everybody come in, no problem, anywhere. Come on in. You are welcome, port number 80. That's how my load balancer security group should be structured, which is what I wrote down here. Anybody on the internet, port number 80, welcome. So that's what my design is. So I configure my routing, my target groups here. We can specify them and associate port number 80, protocol, HTTP in our example. And the target type can be either an instance or an IP. I don't have any machines running there, but my idea of a target configuration routing is basically going to be mapping to these instances. That's what I really want to do. So this one, I will leave instance as my selection, give it a name here. So target the underlying application instances like that, and create the target group for port number 80 HTTP traffic to target the instances I will have inside. And then I want to check the health of these systems on the underneath on the application subnet. So I will look for HTTP protocol at this path and see if the machines are actually healthy or not. And we'll then register the targets. Cannot contain spaces, fine. What about now? And then I don't have any instances here. So that is okay. We can add that instances later once we get them created. I review, and then I create a load balancer. As soon as I create a load balancer, it will start looking for instances. So that's the overall idea of creating a load balancer, and that we need to map that load balancer back to machines out here. So A and B, sorry, rather, I should call them application 1 and application 2 or something like that. So we have to have those boxes and then have a load balancer connect to it so that it actually responds to people on port number 80. Now, in order for us to run a simple example, for us to see these things live, we need to have real thing running on the cloud here. We need to have a machine here and another machine here in the A versus B application subnet, and then have these machines actually do something useful, something meaningful. and then have a load balancer that connects to them, and then have a user visit and actually examine and explore and understand and play with and all that good stuff. That's what I want to actually demonstrate live, which means I need to find some application, put them on these boxes right here. So I will do that first and then come back and actually create a load balancer when we are ready with the 2 application boxes. That's the plan. It will involve me creating 2 machines here and here, putting applications on those 2 boxes, then come back, create load balancer and connect and demonstrate. So we will be able to play live.
So can we take a break first?
Yes, thank you. Yeah, thank you. So I'm going to run a timer, and here it goes. Timer 7 minutes, and off it goes. Sorry about the delay. I guess you're back. I just came back. A little late. But let's get to work. Checking if you are back. Looks like you are. Okay, so let's proceed. What I intend to do is, first one is go back to our machine creation step and create two machines. Let me go to the screen here. I want to create this M1 and M2, like here M1 and M2. I want to create them. I will choose to create Ubuntu Linux. That's my choice. My choice for today. And there we go. So we'll say AWS EC2 and select a operating system of my choice, Ubuntu, and say T2 Micro. Configure the details of this machine, give it to me in the CloudGenius VPC. And by the way, I would like to get this in the application A subnet. And don't give me a public IP. Do not. That's my choice. And similarly, I will add some storage and add some tags and select my security group, choose an existing group that I have already called app, which allows me to connect to these from the NAT. By the way, remember, our security group is currently only from NAT. I have to expand it later on to include traffic from the load balancer also, like I called out here. Like this portion I have not done yet. We'll do that later. Review and launch. So this launches one machine and it goes. So I'll select my key pair and say launch it. It's already launching. I will go another machine. So now instances, one more. EC2 dashboard, launch another instance of the type Ubuntu and T2 Micro and my VPC in the US West 2B application subnet. Don't give me a public IP. Do not. And add some storage and add tags and security group. I want to select is the application security group, like that. Review and launch. And it launches. And like this. And launch. And then I'll create a NAT machine, the network address translation machine, which is going to be running in my border check subnet. So I'll run one NAT. I can actually run, technically I should run two NATs. These two NATs will allow me to load balance and provide higher availability, so that if one segment is down, it can flow the traffic through the other. That's how you should design. But for our example, we'll just use one NAT. So NAT, just simplicity, AMZN. I'm selecting a NAT that I have here, and I just grab it, select, and then T1 Micro not available. What does that mean? Oh, it's an older machine, I guess. So we'll go select, say this machine, it's NAT HBM. So I'll select that. It says yes, I want to continue with this one. Fine. And go next. And then I have a T2 Micro choice, which is a free tier eligible. And I configure my details. This machine I want to get in the CloudGenius VPC and in the border check subnet. I can select A or B. It doesn't matter too much. I'll just go with A. And this machine, I need a public IP. As you know, I want to connect to it. So I create a public IP and get from that machine in, put in my border check A subnet in the CloudGenius VPC, add some storage, and then I add some tags and configure security groups, and I select an existing group that I have already called NAT. And there is a question from Rob, so go ahead, please.
So you said that you're only going to do one NAT. Could you conceptually put that on the picture? Because I'm not sure how you can use one NAT when you have two subnets that's load balancing.
Okay. So let me get some NAT device. So here is my NAT. Here. I'll get this NAT and put it this in my bring to front. And so this machine, I bring it, put it on the A side. And what will happen is the traffic from these boxes will flow through this NAT and go outside wherever they want to go. Like that. As opposed to a failover NAT you can have, which will look very similar, but it will be in a different location, and you can have the NATs go like this in case of a disaster.
Okay, I got that. So is this just going to be the outbound, or is this going to be for us to connect back into it also?
Technically, if you go strictly pure people who will say that, NAT, don't bother messing with it. I think that's the right approach. So, I should actually use something like a jump box. Let's call it our jump box and put it right here. And this is the only box that I want to, then maybe I'll create this jump box right now. And this is my NAT. This is my NAT device. This is my machine number 1. This is our machine number 2. This is our A zone. This is our B zone, like that. So what I want to actually do is actually use a proper jump box from which this is me, from my home, connect to the jump box and then go in, do whatever I want. That is what I think I should do today. So I will create another box called jump box and go through that as opposed to going through the NAT like the last time. Now I will create only one NAT, but you can have 2 NATs or more NATs if you like, but 2 is good enough. In production deployments, you typically would use, in case of Amazon Cloud, you will use a NAT gateway, which already gives you 2 NATs. So it already gives you a highly available NAT setup. Okay, so let's go proceed. I just expanded my design a little bit more, which means I'm throwing this other complexity of making sure, excuse me, making sure that I am not jumping through NAT, but actually I will be creating a separate box here called the jump box. I will also not be creating this NAT, just to cut on complexity. But given that you already understand, so there's no need to. You can always create any number of machines you like. So this is my design that I'm implementing. I just have finished creating this one and this one. This I'm about to create, or maybe I did not. I'm about to. So I'm creating this NAT device and reviewing and launching. It will go and fit in the, which AZ I picked. I don't know. Instantly, it'll tell us. I think I chose A probably. Then I launch the machine and select my key pair, and it should launch my T2 micro machine of the Amazon NAT type. And let's go launch it. Then I'll review the 3 machines I have now. So I have one machine here, which is going to be a Amazon NAT, and it is going to belong in US West 2A. It has a public IP address coming up, which is this one. And I have 2 more machines, by the way. So these are the 2. So let's call them. Like, this is my NAT machine. No. This is my NAT machine. How do I tell? By looking at the IP address. If I have a public IP, that means it is a NAT. You can also tell by the machine image that it's a NAT right there. The other 2 machines I have is, one of them is in 2A, the other one is 2B. Those are my M1, M2s, like I mentioned. M1, or rather I should call it MA. How about that? To make it more meaningful. And this is the machine in B. So that I have the 2 names instead of MA and MB. I just renamed them. I need to create a jump box for us to be able to jump in. So I will have a jump box. The NAT device that I created, by the way, needs a setting change, like networking, change host destination check, So I need to do that, disable. Remember, this has to be done only for the NAT machine, not for any other machine. So I did that. I need to create one more box that is going to be my jump box. So I will create Amazon Linux and configure the details, put this in the CloudGenius VPC, select this machine to go on the border check B subnet, get a public IP address.
Sorry, what was that? What was that special thing again on the NAT machine, which you told us last time too? But
I'll do that. No worries. So I'll just let me finish this. I'll come back to that. So this machine, we are creating a jump box machine in the CloudGenius VPC, border check B, and then add some storage to it, get a public IP there, and add storage and add tags and security group. What I want to create is a new one. This is going to be for the jump box, right? So we have to create a separate dedicated idea for JB jump box. And this will allow me to go in from my IP. So that's the purpose. And we review and launch this machine like that and say the key pair, and boom, that goes. Now back to the question about what did I do about the NAT machine that is specific to that just one machine. And that idea is called on the NAT machine. Just the NAT one. What you need to do is to disable source destination check, like this idea. This source destination check is to be false. It has to be false for the NAT to function like NAT. You see, NAT is a bunch of liar. Like it masquerades. Like, and I think the correct spelling of liar, I think I wrote it wrong. It's L-I-A-R. If that's right, I think it is the right one. But English is my 9th language, so I hope you will understand. Yes, this is the right spelling. So liar, they lie, NATs lie, they masquerade, they pretend to be somebody else. And so when they're pretending, the source of the traffic and the destination of the traffic do not match. That's what this setting prevents. This setting, the source destination check, indicates whether source and destination checks are performed or not, where the instance must be the source and destination of any traffic it sends to and receives. So read that description here. It clearly tells you that this setting basically enforces the traffic originating from that box, the destination coming back to that box has to be the same. But that is not the case in case of NAT, because NAT is a masquerader. It pretends to be the internal machine that you have, like machine A, machine B. And therefore, the destination of the traffic is the other machine, not that NAT box. The traffic doesn't stop at NAT. It goes all the way inside when it returns. Therefore, this setting is necessary to be disabled.
is it possible to change that later? Do you know?
Of course, you can toggle it anytime you like change source destination check and enable. Now the NAT will not function like NAT.
That's what I was looking for. Thanks.
And then you remember to change destination source check and keep it disabled just for the NAT. And so it is false, good. For every other machine, it is true. And that is nice. So now we have 4 machines ready. So what we have now in our picture, bring it back here. In the picture, I have this ready, this ready. So 4 boxes ready. Okay. I need to now focus on our security group clarification. Right? We have to create our security group structure very clearly. So I will go and write that down. I have created a new security group called Jump Box. Jump Box allows me to come in through port number 22. And I would like to go to any other box. So I have to expand my definitions of other boxes, other security groups, to allow traffic coming from Jump Box. So that's what I will be expanding scope of all other security groups so that the Jump Box group will be let in. That's what I will be doing next. And this security group changes can be difficult to comprehend. So just pay attention. What I'm doing is going back to the security group selection here. And in there, I have a bunch of them. I will accumulate. And this is the Jump Box security group. Jump Box security group. So what I'm doing now is the applications machines that are in the application security group, they should allow me to go in, and I will be coming in from the Jump Box. So inbound route expand and add another rule to allow traffic coming from, as long as it is coming from the jump box. Like that. So if the traffic is coming from jump box security group, please allow this one. Allow jump box. And so I save that one. Save. And that I expanded the application security group. I will now visit the other ones like NAT. Do I need to go to the NAT boxes just to examine the NAT? Yes, I would. So I'll add another rule and say, hey, please let the traffic from the jump box to come in. Like that. And so I save this one. Save. Let's see the other database security group, inbound traffic. Do I want to go to the database servers? Yes, why not? This is me, right? So I want to go anywhere I want. So I say custom and say jump box and allow. So I'm basically allowing traffic for jump box to come in. There is this default VPC security group, this one that was created. We can expand that one also, but we are not using the ignore one. So we are basically ignoring that. That one I expanded to allow traffic from jump box. NAT I expanded from jump box. Jump box is already allowing me to come in. Applications are allowing the NAT and jump box. So that's good. Now the piece that is missing is I would like to have my application security group allow traffic coming from the load balancer in port number 80. So I'll do that piece. In the application servers, I have this application security group. I need to have any traffic originating from our load balancer for which we don't currently have a security group. So we'll create one and we'll say this is our load balancer security group. And the name description is load balancer. And it belongs to the Cloud Genius VPC. And the outbound traffic is all fine, but the inbound traffic, I would like to get a rule in place that you allow HTTP traffic coming from anywhere on the internet. So load balancers, that's what they do, right? Receive people's traffic on the planet. So load balancer security group inbound rule allow any traffic from anywhere as long as it is coming on port number 80. So let customers in and via HTTP to be specific. So we are creating that group like that. So that load balancer group is created. So this is our LB group. And what I want to now do is allow the application security group to receive traffic if it is originating from the load balancer. So in the application security group, I want to expand my rule and say if there is traffic coming from, if there is rather HTTP traffic coming from the load balancer, take it. So I take that traffic into the application security group. That's what I just edited, my application security group to allow traffic, HTTP traffic, as long as it is coming from the load balancer that I expanded. Let's see what our security rules are. I think most of them, I think I have taken care of from my intuitive understanding of what I am trying to accomplish. So now is a good time for us to create the load balancer itself. Load balancer is found in the EC2 segment, in the EC2 dashboard at the bottom. You can also find that load balancer in another location in the VPC section, but we are just here, so we just use this section. So load balancer create HTTP load balancer. The name is going to be LB. It's internet facing HTTP protocol, and I'm avoiding the HTTPS protocol for right now because I'm not in the mood of bothering about SSL certificates at this moment. US West 2A and border check A, US West 2B, border check B. 2 subnets selected, 2 availability zones selected, configure security groups. And I say I'm not using secure listener, which is fine. I go to security group section, create and select an existing group that I have already, which is the load balancer, which is what I want. So I chose that. And then I configure routing. And in here, I will say, give it a name. So the machines I have are machines in the app group, and allow them to listen for HTTP protocol, port number 80. The target is going to be my instances. The health checks will be on HTTP protocol, and we proceed to register the targets. Now here I find that there is a question. Is there a question? No. There is an open issue from Amazon. I don't care about right now, but there is something going on apparently in Amazon. So we can read that as to what's going on. And it says RDS operational issue, whatever. We are not using RDS, so ignore that. Next one, what I want to do is tell this load balancer to listen to those two boxes that I have, M1, M2, right there. So these guys, so no, sorry, oops, erase the lines. What I'm really doing is allowing my load balancer to balance the load among these two. So this is the LB, this is your MA and MB, this is your JB, and this is your router. So I am asking my load balancer to balance among these MA and MB. So I'm going to select those guys. So here's my application here and another one here. Those two, I would like you to spread the load among those two boxes. So I'm saying instances these two. Don't put the traffic on a jump box or a NAT box. That's not the idea. Put the traffic that you receive from outside, send it to the application subnet inside. And the two boxes are MA and MB. And I said, fine, go ahead and create. So it will create the load balancer right now. And it's created, it is ready and functional. And it is trying to listen, but there is nobody responding, so it will fail because there is no application running at port number 80 on the two internal machines. We have nothing running, it's just an Ubuntu box. Here we have 4. Out of them, MA and MB are 2 Ubuntu boxes. So I need to get to them and put some application up and running in those 2 boxes. So I will do that next step. What I'm trying to do is get to my virtual machine so I can get in. And I will configure my config file, as you remember. With my jump box in place, I will be able to do that. As opposed to using the NAT box, I will be using jump box. I'm waiting for the machine to start, and while it does, what I'm going to do is grab these IP addresses from here, first of the jump box, and then make a connection to the jump box. The jump box is a public IP, so that's the one first thing I need is the jump box public IP. I'll grab it and go to the machine here. It's starting up and almost started. Come on, there. So in my terminal, I will open up Atom for the .ssh folder where I see my SSH configuration, the config file. And in that file, I will edit in this config file. What I intend to do is, first thing first, change this NAT. Is not, I'm going to use the NAT. Instead, I will be using jump box. I'll just call it jump box, like that. So I changed it here also, by the way, simultaneously, the multi-line edit. As you can see, Atom is capable of editing multiple lines at the same time, like this. So that's what I'm doing, jump box. And I just finished that portion. I want to change my IP address right here with the actual one for the jump box. So here it goes. And I save. The user for the jump box machine is EC2 user because I chose Amazon Linux for my jump box is Amazon. Therefore, the user is going to be EC2 user. I deliberately made that choice to make it easy on you, but you just need to remember. Easy because the selection line number 6 is already made for you. You don't have to change it. That's why I chose. The other 2 machines that I have, M1 and M2 inside, are pretty similar. They are Ubuntu boxes. So I'll create one more entry like that. Rather, I should say one more entry like that. And I will put the 2 internal IP addresses. One goes here. The other one goes here. And those 2 internal IP addresses are available to me for MA and MB. The IP addresses are, this one is the MA, I think. So I'll copy that and put it here.
Nilesh, when you're in here, you see where you have the IP address for host, but you're using a name up above.
Even this private DNS?
Can you use a name in where the IP address is?
So this name you can use provided it is a DNS resolvable name, but this is not.
That's not helpful. So you can't use like a shortcut or anything. That config file doesn't allow for a shortcut and an IP address.
It does if it is resolvable, but this is an internal name.
Okay.
only Amazon,
that's-
only Amazon
okay.
knows about this. So it's a private DNS. We don't know. Our machine here doesn't know.
But the jump box up above,
But this one, yeah, yes, you're right. But Jumpbox doesn't know. Once you
so you have host jump box.
we'll
Can we
experiment.
do host?
Hold on, we'll experiment. I think you have a
Oh,
point.
okay.
We'll experiment with it. I understand your point.
Okay.
We'll play with that game and find out what actually happens. So MB, I'm copying this IP address for the second box, putting it right here. That one. So we have two boxes ready and two names like that. I think what you have in mind will work because Jumpbox knows about the internal DNS resolution. So it will work, but we'll verify that. Right now, just go with the IP address. So we have this new file configuration set. This is for machine B. This is for machine A. And the first one is for Jumpbox. So we'll save it, close it, go to the terminal and say SSH Jumpbox. And it says, okay, come on in. So I'm connected. Nice. I exit. Next, what I want to do is go to the app machine number 1. So machine number 1 IP address is this. So I copy that, go to the terminal and say review rm-rf known host file, just to tell you that it's a double jump, 2-hop jump. So we'll go SSH IP address, oops, SSH, and then IP address was, where is the copy? That one. So please copy this, copy, and bring it here, paste. And it should just first connect to the jump box, and then I say yes. And then it connects to the machine inside, and I say yes. And now I'm connected to the machine inside. This is your application machine number 1. It has the 1187 internal IP address, which is matching what you have here. This is the MA, that machine. While on that machine, what I want to be able to do is to see if this machine will be able to install an application for me. So what I'm doing is I'm connecting right now, sitting on this machine, and I want to install some application right here. So first thing, I want to check whether I can actually access the internet using the router I have in place. Can I get to the world outside? Let's go examine that piece first. Right? What I'm trying to do is sitting on MA and trying to go outside, get some application to install on MA. That's what I'm going to do. So I need to go do some installation steps, which means I need internet access on the MA box, which means I need to first check for access. So we'll do that, check. Here, can I ping yahoo.com? No, that means something is broken. So what is broken? Security groups. Let's go examine those. So we'll go examine here. We'll check our NAT security group. Does it allow any incoming traffic originating from the application? The application security group is actually starting the traffic, say ping yahoo.com. So does the NAT security group that we have here, security group called NAT, does it allow any inbound traffic coming from the applications? No, not yet. It allows from Jumpbox, but it doesn't allow any traffic originating from the application security group yet. So we need to expand this and say add a rule that allows any traffic as long as it is coming from the application, so that the app boxes can update themselves. Go ping Yahoo or go ping something like the Ubuntu update servers and install some applications or things of that nature. So that's what I'm doing here, is adding another expansion of the definition saying this application, let's be clear, this application security group, as long as the traffic originates from this source, please allow to come into the NAT. And when it comes to NAT, it will be handled. The future traffic will be handled automatically. So back here, now we'll go again and say ping. And does it ping? Huh. Why does it not ping? Let's go read the security group's remainder sections. Outbound traffic is allowed for you. Application. Sometimes the challenge that I have seen is the Amazon NAT boxes don't necessarily perform like NAT. That's why I have come up with this solution, which I mentioned briefly the last time. I'm going to pull it out again, and I may have to apply that thing right now. Is the build your own NAT solution. So I will be able to use this as a solution for myself, because I have seen that NAT boxes sometimes don't behave like NAT and they get stuck. Like this one is stuck right now. So if I say, it is not able to resolve ubuntu.com, it's not able to go there to this address. That's a challenge because traffic doesn't seem to flow. There are several reasons for this traffic not flowing. One of the basic reasons is the NAT has to function like a NAT. The NAT traffic to go outside is allowed. I'm just cross-checking my security group rules before I extinguish and terminate that machine and create a new one and create my own NAT. That's what I will be doing. Or in the inbound sections, I'm allowing traffic coming from the application security group. Yes, it does. Then my applications are wanting to go out. So the outbound traffic is open. It goes to the NAT device. NAT allows traffic inbound from application, so it should function. Let's go back to the machine here. Is Travis on the meeting right now? Travis?
Yeah, hi.
Hey, do you know what happens with sometimes the NAT doesn't function, you mentioned the last time?
I was having problems when I was using something other than the NAT AMI, but we worked through that little masquerading IP tables.
Okay, so you used Ubuntu, right?
Well, yeah, we did that little exercise and used normal vanilla Ubuntu, and then put in those couple commands to populate the IP tables rules.
Okay, so I think that's what the resolution would probably be. So I'm going to delete this NAT machine that I have here, completely extinguish that.
But if you got that VPC NAT Amazon image, that should work without doing anything to it except for that source destination check.
Yeah, which I did. I have it false, and so it should function.
Yeah, I didn't ever have a problem with that particular situation.
Okay. So
that's why you shoot the cattle. Right.
So, let's kill this and get a more later NAT. This is slightly 2016 NAT. I don't know why I selected that one. But
maybe that's it. Yeah, I did a 2017.
Yeah, this is a 2016 NAT. I think I chose the older one. Maybe it's not functional. Yeah. But I kill it. T2 micro instance state, terminate, and go bye-bye. And then launch a new instance choosing the community AMI and then Amazon NAT. And here we have the later NAT here, 2017 NAT. So this one, select and create a T2 micro configure in the CloudGenius VPC in the border check A and get a public IP and add some storage and add the security group. In question for NAT is going to be review and launch. So we'll go and launch and wait for it to boot. And then we should, oh, you know why the traffic is not flowing? Because we haven't actually, stupid me. We ignored our black hole. Our routing table is still dangling. It doesn't have a thing to go and put its feet on, right? That's the reason why it's not working. So I unnecessarily deleted that, but no worries. So you see what I just remembered. In the CloudGenius VPC, the last time we had these, route tables, the public route table has a route to go to the internet through the gateway, which is fine. But the private area, the private subnets, these subnets don't have a route to the internet. That's why it is not working. So now we'll get to work. We'll get it to work by selecting a route to the internet. So we'll go edit and add another route and all that good stuff like 0000/0. That was missing. That's why it was not working. It doesn't have a route to go, so it gets stuck like this. Unable to resolve. I don't know what to do. I don't know where to go. So break it, come back here, go to that machine, make sure that it is source destination check, make it false. So you have the machines up and running there. This is the dead NAT, so we'll call it dead NAT. And this is the right NAT we have, the current NAT. Now in that NAT, I want to make sure to go right-click networking, source destination check, and make it disable. Now once you do that, then NAT becomes functioning like a NAT, but our dashboard, VPC, route table, public route, private route table, and the route doesn't have a route to the internet. So we'll go and expand it and add another route to the internet, and then go to the target, and don't select Alexi, which is our gateway, but instead select the NAT machine here, which is number Foxtrot 7 Echo Echo, this NAT machine. So that's the machine that I have selected and saved. And now you go back here and say ping, and it pings. Immediately starts to ping. That's what's going on. So now we can update the machine here. And at the same time, install some application right there. App-get, so it is installing something and updating and installing. And so we'll have an application running right here in a minute. And we'll do the same on the second box. So it is doing that right now, installing a simple application called Nginx, doing it. In the meanwhile, we go to the second box, and the second box is a different IP address. So we copy that IP address, go to the other terminal here, and say SSH, the other box, and we get connected to it. And now we are there. So here we say ping yahoo.com, and it pings, and that's great. So we go sudo apt-get update, and install some application on this box. So it's doing it. And now we have two boxes running the same application called Nginx. How do we know that it is doing it? So the first box, you can see that it is running Nginx right there. We cannot open that in a browser on localhost because the localhost is not really local. It's away from us out there in the cloud. Same thing here. It is running Nginx right there. The application is running on those two boxes, which means we can go back to our load balancer, which is somewhere here. Where is that? Oh, they hide it. They make it so difficult. But okay, let's go to EC2. That's where you find load balancer. And in the EC2 section, you will have the load balancer in the left section right there. And there you will find our LB load balancer. This one, we have two listeners, and the monitoring action, and the description action. And so let's go see the listener details we have here. And we'll also go find out what they are listening to. So description, and where are the machines? Targets, edit, and here I want to select the two targets that I have in mind. Now this is first time you're seeing it, so I just want to make sure that I get to the right location. What I'm doing is I go back to my load balancer, which is, it is slightly hard to find. So let me begin from the beginning point. Go to the dashboard, go to the load balancer here. That's where you will find your load balancer running. Now in there, you will also find a listener, which has a rule forwarding to machine. The machine is our target group, which is also accessible right here. They have just changed the location for us, on us. So the target groups are here. We have one target group called machine that I named, and in there are no currently selected targets. So I will have to select my targets, edit, and say my targets are this box and this box. Those two are the boxes that I need to add as my targets and register them as a part of the load balancer. So they become a member in our list of targets. Now we'll see whether the health check will succeed. The health check should succeed in a minute or two, as we find that these two targets that are still not showing, did I not save it properly? So I need to add to registered. Okay, add to registered. So I need to have these two guys now added, and then I save. Then they become available. And currently none of these targets are healthy, and because they are just added, so it needs to go and check for health of these targets, the two machines they have. So the two machines we're talking about are these two machines. We just included them as a member or rather target for the load balancer to actually interact with. So what we just did is let load balancer know that you can balance the load among these two. So now what load balancer is doing right now is to say whether these guys are healthy or not. If they are not healthy, it will remove them out of the workload. Meaning if this officer goes on lunch, then there is only one desk and all the load goes to that one officer. Same idea of the DMV, the Department of Motor Vehicles, same idea. You have here, the load balancer will actually see if the officer is in service, in duty or not. If the officer goes on lunch break, then the officer is gone. So when you don't have a solution, in that case, you just have only one healthy machine. Right now, if you check for health, the health check actually happens on HTTP protocol, on the / path, look at the traffic on the port, which is port number 80 that we have defined. There is a healthy threshold, there's an unhealthy threshold, there's a timeout, interval, and success code should be 200 OK on the HTTP response. With that health check in place, let us see whether targets are actually healthy. And now it shows that it has found the two targets as healthy because the underlying machines, sorry, not here. The underlying machines, our MA and MB, what doesn't it write properly? MA, MB. Yeah, these two are running an application called Nginx right now. And so our users, when they visit this endpoint, they will be handed off to either this box or that box, depending on what the load balancer decides in an algorithm, which is typically round robin. So A, B, A, B, A, B, that's how it will roll and rotate traffic among, depending on what the algorithm chosen by default is round robin. That's the algorithm. We have these two machine instances that are in two different availability zones, A and B, both healthy. So now we can actually look at our load balancer. Hey, load balancer, what is your description and what is your DNS name? So that's our DNS name for the load balancer. Let's go copy it and see what we see. So here I'm going to open it in a browser and say, show me what you got. And what I get is what I expect, is my application running right there. It says, welcome to Nginx. You can now see that I just did, what I did was in here. That's my link, the load balancer front end. So you see that this one is showing me Nginx, which is running under the hood, running here, or maybe here. I don't know where it is running. It's running on both machines, by the way, but I don't know which machine was I routed to by the load balancer, because I am sitting here right now and I am opening this website. And so I have no idea to tell. And I don't need to know. That's the whole idea of load balancer. I don't need to know whether it's this box or that box, because I don't care. I don't care whether this machine is the MA or MB. I just go there and I just see what I expect to see, which is the application running, and that is nice. While I'm doing this, I would like you to also click on the same link I gave you in Slack chat, and you should see the same thing, because that's what it's going to do. But what will happen in effect, in practice, is that each one of us, when we visit, that we will be routed to either this or that in a round robin fashion, as you will see in an example. So what I will do now is go to that machine that we have here, like one of them, and in the other machine, like what was the other IP address? This one. So 2 machines are connected to both of them. Now let me do some hacking, like very simple hack. What I intend to do is I'll make some modification to these 2 boxes to make them look slightly different. Let's see if I can quickly hack it. So this hacking is based on Nginx. So there is this HTML file that is sitting in that location, which says, welcome to Nginx. And so here is your title. It says, welcome to Nginx. So I'll say this is your machine. Oh, I need to come with a sudo. Hold on. So sudo vi index. And then I will change the label right here a little bit. And this is like hacking, by the way. Don't do this in real life, but I'm illustrating a point that I will demonstrate in just a 2 minutes. Just the hack needs to finish. So I'm saying this is the machine A, and I will save. I'll do the same thing on the other machine. And on the other machine, I will hack it to be machine B. And then I save. So now I have modified my 2 machines to show us slightly different outcome deliberately. So when I refresh my browser, I should see something different. Either I see machine A or machine B. I don't know what I see, but let's go play. So I refresh and I see no changes because it is not done. It probably did not do the updates. Let's go see if I can actually
restart the servers. It's probably
I need to restart Nginx. I think it should not be needed, but maybe it takes a time. Let's go find out whether it's showing us something. Did not pick up. I thought I hacked it. Maybe the hack did not succeed. I did not succeed the hack. Okay. Maybe it is not the right file to change. Maybe it's some other location. So let's go service. And then curl. No, I think the hack did not succeed because I'm not hacking the right file. What I was really trying to, maybe we would go exactly find the right location. Maybe that was not the right file to go and find. So I don't want to waste time in hacking. But what I really want to communicate to this key idea, which is like this, that if you have subtly different content in the 2 machines, MA and MB, somewhat different between this machine and that machine, the output that these machines will generate for the user will be different. But that's expected. You don't want them to be different. You want them to be identical in case of a large scale deployment that is scalable out, horizontally scaling out deployment. You want them to be exactly the same, consistent experience for the end user. But for the hack, what I was trying to accomplish is that you can see that the round robin algorithm in play. When a user comes in, you will see that some of us will see MA and some others will see MB. That's what I was going to demonstrate, but it did not. The hack did not work out because I'm probably not hacking the right file. When the correct file gets hacked, it should show us MA and MB differently. I think it's some other location. So I'm not hacking for that.
Check if there is www directory.
Okay.
At the same level as HTML. Just go one up. Yep.
Check to see you actually edited those files. I think you did.
I did.
So
Maybe it is this. Maybe it is this one. So maybe it's a different location.
Yeah. Well, when you were editing them in VI, I don't know if you actually.
It is this
saved
location probably. So we should succeed in the hack. I think we found it. Let's go find out sudo vi. I think it is this, but we'll just quickly test. Make some little modification to this one, saying this is MA, whatever. Let's go see, save it, and come out, curl localhost, and see what do you see. curl localhost. And what do you see? Yeah, we succeeded. The hack succeeds. And so we should now see something different. So here we go. What do we see? MA, right? That showed up right here. And again, and again, and again, and again. And if all of us like hit the same endpoint at the same time, you will see random behavior, like, jumping from A to B, B to A. This is B, this is A, this is B, this is A. You see the jump happen as you see load balancing, as you saw in this example. Now back to our console in EC2. What you can do further is adjust some properties right here and maybe modify the characteristics of this load balancer to adjust stickiness. So the stickiness is another idea that I want to call out, which you probably understand it, but if not, I will clarify. What I mean by stickiness is that you want to associate. Where is the stickiness function? They hide it. They keep moving things around.
So is it under targets? So go to targets. I saw something that might be there. And no, it wasn't there. There was something that, go back to listeners. There we go. View edit rules. Do you know that might be where it is?
No. I'll find out where the stickiness properties are. There are two ways to do stickiness. The stickiness idea is basically, let me describe what that means. So the stickiness idea goes like this, that you want people to get a session established. Let's say, for example, these two people we have here, right? So let's go erase these guys. Erase. And we have two people, let's say person 1, person 2. And these two people at the bottom here. This is P1, this is P2. When a person 1 comes in and person 2 comes in, you want that person might log into a session with and gets associated with this machine. So the idea is that once the person is logged in, that you should continue to serve that person from the same location, which has generated content for him or her. And that can be established through this idea of whenever this person comes in again, that person should be allocated to the same box so that they don't get logged out, LOGG, log out. You will see sometimes, when you have like, for example, Rob was running into the problem the other day when he was playing around with his virtual machines and some cookies. And so he was logging onto this website. And as soon as you go to the technology section, apparently it was logging him out for some reason, or maybe he was just not presenting the right page, was not presented to his browser. Now that we have to root cause as to what may be happening, but bottom line is if you have multiple machines like this, you need to ensure stickiness so that the user who logs in should also be serviced by the same machine over and over until the session dies, until the user goes away. So there are two ways at least to enable this stickiness behavior. One, you can do it right in the load balancer itself, which is not my preferred way, but it's a totally legal way of doing things. You can do it that way. I would rather do it from our application level so that we know who's managing the cookies. So when you have an application here, that application should generate a cookie. So the cookie that you generate gets stuck with the browser here, and that user will automatically be routed to this destination based on the cookie handling that you are dealing with in your application that you run. And that's one way to handle cookies. The second way is to let this load balancer manage cookies. The setting on that browser interface on this website as to where you manage cookies here is kind of hidden, but I'll find out and tell you where it is, somewhere where it's there. That's not my default way of using. I would rather deal it in the application layer. So I control my cookies myself. That's how I operate, but the choices are available to us. So with this understood, I would like to ask if you have any questions on the idea that we just discussed today in terms of running an application here and A and B, two boxes, and we are able to divert or rather balance the load among two different boxes running the same application, Nginx. And we discussed a bunch of things like We discussed security group aspects, discussed the idea of creating a jump box, idea of routing through a NAT device, and the idea of a load balancer, the idea of it's being listening to two different locations. We're looking at health check concept, the concept of checking if the health of this guy is okay or not, if this guy is okay or not, if they're responding to a port number 80 protocol, HTTP, are the machines responding to a health check? And if that's the case, then load balancer takes them into the fold of sharing the load among the two boxes. Now, for some reason, if I go back here and say in my machines that I have, so my instances that I'm running here in EC2, I have MA and MB. What if I just delete one of those guys and say you die? So I say you instance state MA terminate. It goes away. Now what happens to the load balancer? It will still keep on functioning just fine. And it will keep on giving us only one output because MA is dead. So this MA dead, that means we are getting the same result over and over again because only one machine is functional because the other machine I killed, it is dying right now. It is shutting down, which means if you go back to the load balancer, where is that load balancer? AWS, EC2, and load balancer, you will find that one of the health checks is failing. If you go to the health check section of listener, machine, and health check, and one of them should be failing. Where is the failed health check? Oh, it disappeared. We killed the machine, so it went away. If we just had uninstalled Nginx and the machine still active, it would show up in the list of actually registered targets and then unhealthy status for the other machine. This is our machine B, MB. The MA is dead. So you can basically programmatically create machines and add them to the load balancer and expand and contract or shrink and grow, or grow as in scale out or scale in on machine performance characteristics. So we'll do exercises more of that nature later on, where you will see that machines start and machines stop depending on certain patterns of performance characteristics. You will see those in future exercises in real live examples. But for right now, a couple of things that we did today that included a bunch of different concepts that I want to recap quickly and make sure that I answer your questions. A couple of things that we discussed, they were like around the whole concept of VPC. That's what we focused on. One of the things that was focused on the idea of security groups, which I think should be clear to you, is it allows a set of rules that defines a source, a protocol, and a port, and whether you say yes or no. That's the kind of set of collection of rules that we have in a bunch of different security groups that we saw here, which are in this section. And if you filter them by the VPC ID, you can then focus on the exact ones. The idea of security groups should be clear, because this is one of the reasons where one of the places which throws people off. People get confused about the idea of security groups. So now is a good time to actually ask any questions if you have about security group per se, because we have a way to help you understand that idea. The idea of security group as such, as to how it allows traffic to flow and how it prevents things from flowing and keep things secure in an area that you control. There is a question in chat, so let's go see that. Where is that? So the question is Kevin Johnston. I observed that setting up a complex load balanced HA configuration takes a very long time. Will we be spending time in AWS configuration or alternative to leverage the use of CLI scripts to build and destroy resources instead? What are the pitfalls of managing resources in this way? Okay, so that's a very good question. The idea of setting up a complex configuration, like high availability configuration, like I just did, it took me like a bit of time to use the mouse and click there and click that and type this and type that. And this is not how things are done, by the way. This is not how you build infrastructure. You build infrastructure using automation tools. And what you are calling here, like leverage the use of CLI. That is exactly the idea, is you write down your thoughts about what you want this picture to look like. You write that down in code, and we will have exercises on that piece. Like, how do you write code to create infrastructure? In fact, that's where the second segment begins, is infrastructure as code, developer operations. How do you codify your concepts in terms of the infrastructure and put that in form of some code, like very simple, but code that you then run on the cloud. I mean, you run it right here in this machine, you run it here locally, it goes and configures your cloud for you. So you don't have to even visit this site. That's the whole point, that you don't want to, I mean, not that you don't want to, but you don't have to. You don't have to go to the VPC and click this button and no, don't do that. That's not how things are done. The reason I show it this way is for the first timer to understand what this thing is. If I just begin with the command line and you see nothing, that's a nightmare. You know, if people don't fathom what's going on. So that's why I show you bit by bit, piece by piece, in a visual fashion, at the same time drawing with a piece of paper as to what is going on. But in real life, you don't want to do it like the browser interface. What you would rather do is come up with a design like this, maybe more complex, maybe something different. And you codify this in simple code. We'll codify, we'll write code. We'll give you examples of how to write code. It's not rocket science. It is computer science. Yes, it is not rocket science. It is easy. And yes, you can do it. Yes, you will do it with me. We have examples for you that you can choose and copy and paste if you like, or modify yourself. But the core idea is to not use that website. No. You codify your ideas and run the code on this machine here, and boom, you get it. That gives you repeatability. That gives you consistency, predictability of a complex design, and make it repeatable for your customer A, customer B, and developers A, B, C, and maybe create a quick staging area in like 2 minutes, create the entire VPC that I have already deployed in production, give me a replica of the same thing right now. Okay, here we go, boom, run a command, and you get a staging replica of the entire set that you have running with live data. Couple of minutes. Maybe a little more than a couple of minutes, depending on how big the setup is. But you can reproduce without making a mistake, because when you use a mouse, when you use a keyboard, you are involving a person. And people are good at making mistakes. And I enjoy making mistakes every time I make a new one, I hope. Not repeat. So by making mistakes, that's how people learn. And so people are prone to making mistakes, and that's why you don't want to have people. I mean, yes, you do need people for thinking, for designing, for creating, but you don't need people to do silly stuff like click a button or type this or type that. No, we don't use people for that purpose. We use people for smart, intelligent things that require brain power, not for repeatable things. We'll talk more about these concepts in the DevOps section, which is going to start someday. I don't know the dates. So you have the dates. So someday it will start, a couple of days maybe. But yeah, there Travis goes right there. So let's see, Travis says registry.terraform.io, and he gave you a link. How can we export your configuration? So Travis is giving you one link, which is my preferred way of using the tool, which is open source, and that is Terraform. Amazon and Google and Microsoft have their own way of creating a export of your config, like you mentioned, like Kevin is saying, export your configuration. For others who do not understand what Kevin is asking, let me clarify. What Kevin is saying is that, whatever I have here in my VPC, the Cloud Genius VPC, this whole design, just give me a export. So then I can take an export from here and go to Kevin's account in Amazon and play the export. When I play the export, when I play, I should say, import the export. Let's use the word export import. So if I export from my account, give that export to Kevin. Hey, Kevin, take this. And Kevin can then import into his cloud. That should construct exactly what I have in my account same thing created in Kevin's account. This kind of an export import business is called in Amazon calls it cloud formation. So they have this idea of export and import, and we'll play with that also later on. But this is one of the services that Amazon provides, and it is only Amazon. That's the problem that I have. I don't want to get stuck with any one company, so I use neutral tools like Terraform, for example. And this tool lets you do whatever you want in any cloud of your choice. So that's why we are, going to use that tool as opposed to using a company-specific tool like this one. We'll use it once, like one time, but that's it. That's the end of it. Recent news of this company. Let's go see what they're saying about Terraform. And so Twitter, I think I saw it on Twitter. So basically what I'm saying is this company, Terraform, there we go. Yeah, here. He says, Rustam Karimov says, 1Password servers will be down for the next few hours. We are recreating our environment to replace AWS CloudFormation with HashiCorp Terraform. It is like creating a brand new universe from scratch. That's a live tweet like from 2 days ago. This is January 20th. Today is like 24th. So like a couple of days ago, this happened. What they did was they took down their entire design from Amazon's implementation that they had. They rewrote the code in Terraform way of doing things, and then created a brand new universe, as this guy is saying, brand new universe from scratch. That's how you do an export import. And
Terraform even has a way to import existing infrastructure through any of the providers it supports.
Yep.
So
I
you
think
can actually go and grab it.
Yeah, that's the link I think you just posted. Is that right?
Actually, you know what? Those are some interesting things I found. Like, Docker's got a registry. Terraform put up a registry where they have modules that you can plug right in that essentially build a AWS VPC, essentially like what you demonstrated.
Mm-hmm. Yep. Yeah. We'll do Terraform exercises, but later on, not right now. Let's first understand the concept, then build on it. Like you just described, the export import is a way to describe the idea, which is I think the right way to think about it. How do I export my configuration? And when you mean configuration, it's actually the design of your implementation of the entire application set, which includes HA architecture, multiple subnets, multiple deployments, security group configuration, how many machines, scaling policy, database connectivity, load balancer, all the things that you will put. S3 connectivity, content delivery, network connectivity, all of these things that matter to your application that will make your application go and run live. You want to be able to export and import that configuration and put that in a Git repository. That's what we will be doing, but not in cloud technologies. We'll do it later.
Yeah, it's good to get familiar with it, and then it feels like a breath of fresh air when you get these tools under your belt that automate it. I think that's the right way to go.
Yep. Yes, indeed. Let's see other questions. We have no questions in Slack chat. In here, we have no other questions. Okay, so I think we don't have enough time. We have like 14 minutes. So what I want to do is ask you a couple of things. The next thing I want to do in our next session is actually do an exercise on Heroku. So what I would like to quickly recap, up until now, we have been discussing infrastructure as a service, somewhat of a software as a service, not much, and platform as a service as the other idea that I want to go. So in here, we discussed storage, compute, and network, which we are doing right now in the VPC and the nitty-gritty and the details behind it. In software as a service, some of you have actually successfully, you are running your own email service you are using some ready-made software from Zoho or Google or Office or whatever you have chosen. You have also stood up a bunch of different services for your own consumption. So I just want to let everybody know that, you can bring your infrastructure down, kill it, terminate it. I don't need it to be running for any reason whatsoever, unless you want to run it, in which case you may want to continue to pay or not pay depending on free services that you have chosen or not. But just realize that anything you create in the cloud is going to cost you money at some point, or cost you effort on some other point to migrate it to another location. It's a service that you're running, like some websites or some email services. Just be aware that I don't require those things, the thing that you have done. I don't need to be running all the time. So if you have created some buckets, created CloudFront distributions, you're free to delete them unless you want to keep them, which is okay, no problem. But I don't want it to be there for no other reason other than the class work. There is no such need to keep it running. So you're welcome to delete them if you don't intend to use those services. So please go ahead, destroy. Having said, some of you are actually interested in having a little site up and running on a cheap bucket. Keep it. Just discard the CDN part. Go back to just the bucket. It will save you some money on the long run. But running a bucket-based site is actually like few cents a year. Few cents a month. So not that big a deal. You can actually do that if you want. Running an email service with Zoho is free today. I don't know what happens next tomorrow. I have no idea. So if you're using Zoho, no problem. Keep using it. You can even ignore to use it if you don't like it. But if you're using Google Apps, it will expire on you. If you are using Office 365, it will expire on you. If you have given them credit card, they will charge you. So if you either don't give them a credit card if you haven't, or you stop the account so that they don't charge you, unless you want to keep using them, in which case it is totally fine. So you can pay just $5 a month per user and keep using them. That's totally okay. Bottom line is, I don't require you to continue to run your homework. That's the key message. Next, I want to go and experiment with a platform as a service next time. What does that mean? It means I want you to create an account with Heroku, this company. It gives you a free account, and you don't even need to give them a credit card. Heroku.com. They are a part of Salesforce.com. You can just create a login and get ready with it. We will do an exercise using our virtual machine. The exercise is written down in our write-up, and that should be available to you. I'll point out where it is there. The next thing I want to talk about is this get-together that we have planned, which some of you did not receive an email from me about a calendar invitation. So I want to remind everybody that it's on 30th. Cloud Genius get-together is where I have invited I think I invited everybody, even though you are not in the country sometime, in some cases, but I still invited you. Who knows, you might actually come and show up. If that's the case, you're welcome. But I know, unfortunately, not everybody can make. So this meeting get-together, in-person get-together, is actually optional. But that's not what I want. I want you to come. It is actually optional. You don't have to attend. But you can and you should, because I think we should get together. Having said this 30th of January, I would really like you to come and join us at this time, 5 o'clock, at this location, which is, let me find out where the location is. It's called Haiku. Haiku is in Redmond Town Center. And so that's the Haiku Sushi Buffet. It has a Boeing discount, I checked. You should also cross-check internal to your company. And we should be able to go have some food here and enjoy and get together, get to know each other in person. What else I wanted to say? Yeah, I already said this account to create on Heroku. I think that's it. So I'm done. I'm breaking early today a little bit. We still have a few minutes. We'll adjust that. We typically go over. So don't worry about the time part. I am going to stop my recording right now and remind everybody that we are again getting together at, what date will that next be? Come on. Today is 24th. So the next meeting will be 26th at 4 o'clock Pacific time, 7 o'clock Eastern time. That's when we get together again, and we'll discuss other ideas in platform as a service and some other aspects of dealing with some applications as we go along. And that's the next idea. So 26th is when we meet at 4 o'clock. 29th, again, we meet at 4 o'clock. And then 30th, we meet in person. If some of you, if you find that that date is not convenient to you and you want to choose a Saturday, please let me know. We can change it to Saturday or Sunday if you like. But I leave it to you. If that's the case, please let me know. We should change it and we'll change it. That 30th date is totally flexible, currently suggested to be at 5 p.m. at Haiku. If you want to change, but many of you have responded okay, so that's a good thing. Don't have to change, but you can. I need to know if you need to change it. Okay, I'm stopping recording right now.